So today marks the halfway point of our algebra unit, and so I thought it would make sense to sort of do a little summary activity that summarizes all the stuff that we've done in this unit, and then get you to do an assignment based on the first half of this unit to see where we're at and make sure we are all on the same page before we move to the second half of algebra. So this warm-up, if you'd like me to ask the supply teacher to pause, we can pause this and you can copy these samples down and then we'll take them up in a second. All right, so hopefully these questions look familiar because it is a summary of the first few days. And so you'll notice the question says simplify. So we need to make sure we use all appropriate rules, whether it's collecting like terms or the distributive property or our exponent laws, to be able to simplify these algebraic expressions. In the first one, you'll see that we're adding and subtracting. So the only way we can add and subtract is if we add and subtract like terms. So we know that we have 7x squared and negative 4x squared are like terms. So we're going to say 7x squared, we got 7 of them over here, and negative 4 over there. So 7 minus 4 is 3x squareds. We don't add the exponents or do anything like that because those are rules for multiplying. So make sure we don't get the collecting like terms rules mixed up with our exponent laws. Here we're just collecting them, gathering them together. We've got 3x's and 5x's. So we just gather them together. 3x plus 5x is 8x. Remember, collecting like terms is like the apples and the bananas. So if we have 3 apples and 5 apples, we simply have 8 apples. We don't have 8 apples squared or try and multiply exponents or anything like that. This is just collecting like terms. Then I'll ask the class, and I know that you're really anxious to answer this. Can I go any further? Hopefully everyone said no. And I'll ask why, and everyone should say these are unlike terms. And so we've simplified it as far as we can go. Now, moving over to B. In B, we are multiplying. So we switch gears and we multiply, and we're now multiplying exponents, or powers. And so we got to make sure we do the appropriate multiplication. So we've got numbers, 8 times negative 2. Those are just numbers. So we think back to grade 4 and 5, when you multiply 8 times 2 is 16. But then in grade 7 and 8, we learned that a positive times a negative is a negative. So 8 times 2 is negative 16. Then we remember our exponent rules. We find ones with the same base. And if we're multiplying powers with the same base, we keep the base and add those exponents. So 2 plus 3 is 5. And then finally, we have a y times another y. And we remember that y has an exponent 1 and 1. So we keep the base and add those exponents, and we get 2. Of course, we know that y times y means y squared. And we've multiplied. So remember, in A, this is collecting like terms, so we're adding and subtracting, so one set of rules. In B, we're multiplying, so we bring in a new set of rules, including all the exponent laws. And can I go any further here? And of course we can't, because these are unlike bases. So this is an x and a y, so we can't do anything with these exponents. We've simplified it as far as it can go. So in B, we reminded ourselves when we multiply powers with the same base, we keep the base and add the exponents. But when we divide powers with the same base, like we do in C, we do the opposite and subtract. So if we have x to the power of 7 divided by x to the power of 2, we keep the base and subtract. 7 minus 2 gets us 5. And it doesn't matter whether the base is an a variable, like x, or a number like 2, it still keep the base and subtract the exponents. 7 minus 2 is 5, and we get 2 to the power of 5, and we've simplified it. So there is collecting like terms, which was sort of day 1, and then we've got day 3 and 4 with the exponent laws. And then finally, our last example here is actually day 2 with the distributive property, because we have 3 being multiplied by 10x and by -4. We stop there because those are the only things inside the brackets. So the distributive law we sometimes call rainbow. So we're taking the 3 and multiplying it by the 10x and getting 30x. Then the 3 also has to get multiplied by the -4, and a positive times a negative is a -12. And then we be careful with E and see that we have -5 being multiplied and rainbowed in. So a -5 times a positive 4x is a -20x. A negative times a positive is a negative. And then on the last one, we recognize it's -5 times a -5 times a -3. So a negative times a negative is a positive 15. We just write down plus. So we've rainbowed, which is a multiplication rule, so we would use any rules necessary there. And now we can collect like terms. And we're going to do our adding and subtracting. 30 and -20. So if we have 30 x's, like 30 apples, and then -20 apples, we're down to 10 apples, or 10x. And then, of course, the -12 plus 15. -12 is pretty cold. If we add 15, we're going to get almost back into the warms, and we get up to +3. I can't go any further because 10x plus 3 are unlike terms. So that's a great summary of the first 4 days of our algebra unit. First 4 or 5 days, depending on how it went. Let's sort of combine a bit of information. So let's take some information from our measurement unit, which was our last unit, and now our algebra unit, and to a question like this where we're finding the perimeter and the area. So we're going to come up with expressions. So instead of having actual numbers, we're going to do the rules with these variables and these expressions. So first we're going to find the perimeter. So the perimeter is the sum of all sides. And since this is a rectangle, if we have x there, we've got x here, and if the top is 3x plus 1, then that's 3x plus 1. And so if we're going to do the perimeter, we can add all of these, go here, here, plus here, plus here. 3x plus 1 plus x plus a 3x on the bottom plus the final x. And we've added all the sides. If these were numbers, we would actually go and add those numbers, but they're expressions now, they're variables, they're terms. So we're going to add and collect our like terms just like we've been practicing. So a 3x can go with this x, and there's another 3 there, and another x there. This is like a 1 and a 1. So 3x plus 1 is 4, plus 3 is 7, plus 1 is 8. And we have a total of 8 x's. And then we've got a couple of numbers, a 1 and a 1, add to get 2. And we get an expression for perimeter. So, we found the perimeter. The expression is this. Let's find the area now. So when I'm doing the area is length times width. So we can call this dimension the length, and we can call this dimension the width. But instead of numbers, we have expressions. So 3x plus 1 times x. You might like to see it the other way around as x times 3x plus 1. Since it's multiplication, it doesn't matter which order you do it. We probably like seeing it this way so we can see the rainbow that's happening. But of course, if we did it this way, the rainbow would just look like this. Either way, it's x times 3x. So x times 3x is 3x squared. Remember, there's a 1 and there's a 1, and we add those exponents. And x times 1 is 1x. Oh, I should have done that in blue. And so then we have an expression for the area. Now, if I actually said, hey, guess what? I know what x is. I'm going to say that x is equal to 2. Well, if x equals 2, I don't need to sub it back into these to figure out my area. I don't need to sub it in here. I can sub it into my expression. So if it used to be 8x, it's 8 times 2, because x is 2. Plus 2. This 2 here doesn't do anything. Now we have actual numbers. 8 times 2. BEDMAS tells me to multiply first. 16 plus 2 is 18. And I would know that the perimeter is 18. I wouldn't have to sub it in 4 times and add it all up. The expression does that for me. Similarly, if I was finding the area, it would be 3 times 2 squared plus 1 times 2. So 3x squared plus 1x. So now it's 3 times 2 squared. BEDMAS tells me to do my exponent first. So 2 squared is 4. 2 times 2. Oops. So BEDMAS tells me to do my exponent first. Now I can multiply. 3 times 4 is 12. 1 times 2 is 2. And I get 14 as my area. Okay, so this is where instead of having to substitute these numbers into all of these expressions up here and try and do the math, we've created an expression that represents the perimeter and area, and it's really quick to do a substitution. So if I asked you new numbers, you would really quickly get the new perimeters and new areas.